still the case, but as I said, like because the runtime is inherently concurrent, and what you are making on App Engine is you are always making some RPC call and waiting for them to resolve. Like you will be able to do things concurrently, not in parallel, but concurrently within the runtime.
Except when something blocks on I/O, you get your thread keeps running, right?
Yes. Yeah. So the thing is that when an API call blocks an I/O, you can process another combination.
Right. So the I/O calls go to a separate.
So those URL, those external fetches, they will actually be parallel.
Yes. They will be blocking threads other than your.
They will happen in parallel as soon as, but for computation, like for the code that you wrote, that is like executing CPU instruction, only one routing is running at a time.
So now you have exercise, right?
Yes.
Oh, yeah, there were the previous steps. Another thing you can do is, as the results come in from both sides, send the individual results to channels. That would be fun.
Yeah. But there is one gotcha with that, is that you have to predict the amount of results that you will get.
No.
Because otherwise you don't know how much you have to read from the channel.
Another channel which says I'm done here.
Yeah,
and if you have two results in those, we can talk about it. So, who wants to code on App Engine? Who wants to do the tour? Or who wants to go home? Who wants to sit around and just ask things? Raise 1, 2, 3, or 4 fingers.
Just one more straight that we need to really at 8:30, so that's in 40 minutes or so.
Evacuate?
Yeah, 40 minutes.
That's all we have to get out of here. Ah, okay. So, if anybody wants to go or wants to ask me anything, like how come these strings in these structs work? Well, that's a good question. Then I'm around and you can ask me. And actually, you can ask him too.
I'll be leaving in a few minutes, Doug.
Oh.
If you have any questions about Unicode or
So Johan,
do it now.
I mentioned regarding the code you showed. So you showed us how you parse XML and JSON. And it basically needs at this item struct, which has an XML.
Annotation yet, but I don't need annotation for JSON because the name of the field corresponds to the name
of the tag.
You can make a list of mappings. So you see that the mapping is tagged with XML, so you can have a JSON and an XML mapping with one field.
This is built on this. I hope it's not important. You saw that it said type something, and then it was a struct.
Yeah.
And then you have these fields, filled, and then you have some type, and then you have this magic string.
Yeah.
So this magic string is built into the language. It's called a tag on a struct field, and the reflection library. You can give an object to the reflection library. It says, "Aha, we have here a thing of type which is a struct which has these fields, and these fields have these tags." So then the built-in reflection can actually look at these tags and do smart things. So what's in the string is defined by convention. So the XML package looks for things of the form XML colon and then something between quotes. The JSON package looks for things that are JSON. The Google protocol buffer, is that public? Not yet, or maybe it will be. So it looks for protocol buffer colon stuff, and you can make your own stuff. You can put your own thing in there for your reflection to play with. And it's great fun.
Are XML namespaces supported?
No. Namespaces.
Yeah, XML.
XML namespaces. Oh. Well, that's a documentation. Plug it in. Maybe ignoring them is supported. So what I know is that it took me nearly 5 minutes to decode KML from Google Maps to make a map for this boat that I took. And I'm pretty sure that KML has namespaces in it. So why? Ah.
So you have plenty of soft drinks here still, right? Like Cokes and Sprites, whatever. If you like something, raise your hand. Just pass them on. Cokes, Sprites.
I had a network.
So you can just look at the presentation. So right now, the presentation, just add slash
Okay. You don't know what's up?
It gets encoding.
But I think that's on the weekly, there's some
Understand XML namespaces. Yeah.
So for Go 1.0,
Yes, the new sustainable release is, yes.
Can I specify several annotations of running cycle?
Yes.
The same data structure, like database, JSON, XML.
Yes, and the reflect package has a convenience function to that works on a tag and extracts the one you want. So you say get tag XML, and then we'll get the XML one, run it to string, and you can look. I'll show you on the computer.
So tag can be combined tag.
Yes,
Yeah.
yes.
Can I use Spot in that?
That would be cool, wouldn't it?
Yes.
Oh, you could, except that's why the package says what's it? That interprets it. Here is no, this is not the one. I wanted to look at reflect.
There's actually this tutorial on XML file interpretation. If you look at it.
Oh yes, there is.
Yeah. If you go back to the
Here, struct tag get. So this is this convenient convenience functions in the yeah, this tag is only defined inside structs. Well, there are questions.
Now that Go 1 is coming out, what's the state of the Go Max proc situation for running Go things in parallel?
You mean the default setting?
Yeah, or I thought, I remember there was not on the mailing list of getting rid of that variable to actually have the runtime determine automatically how many cores do we have.
I don't believe that's in Go 1. Still, the scheduler really needs to be.
Yeah, but it's something you could publish in the future version without changing the Go 1.
It doesn't change the API. That's right,
Yeah.
right. Doesn't change the API.
So what did change though is that in the init calls, you can actually now have Go routines.
Oh yes.
So
That
that's-
used to be a major drawback that Go routines, you could create them, but they wouldn't start running until main started, which meant that if you made your nice XML parser to initialize stuff, you couldn't use it in it.
Yeah.
So that was, and originally they thought it was going to be hard to prove that things couldn't crash, but turns out they don't crash. Therefore, yeah. So, but they still run on. You don't get more threads. It will be definitely one thread during init, but you can already have one routine.
I am used to Python, so I really like that you can have multiple return variables for your function calls.
Oh, you can have multiple return values for your function calls.
Exactly. I love that. That's really cool.
Yeah.
But I think it's weird that it's only the built-in things in the language that can choose between having one or two, like with the dictionary, where you can get the key or get a zero value if there's no key, or you can get the
It's
okay.
not entirely true. So the receive and send statements are bits, and the map lookup are
Yeah,
bits
yeah,
special in
yeah.
that sense. But for functions, let's go to the. So, if you have func f that returns what does it return? It returns a and b who are ints. Return 1, 2. Then let's see, how was it? If I have
So it's a question.
You can assign this to a struct that has the same format, if I'm not mistaken. Maybe I'm mistaken.
I know you can pass it to functions that take two
Yeah.
arguments.
Doesn't this work?
Never used that.
Maybe it doesn't.
I don't think
Maybe it was a bug and I fixed it.
so. Why?
Oh,
Definitely.
I would of course also convert this to get the A, for example, and then optional B. Like,
Yeah, no, you cannot do that. So
okay,
you have to have always
I am
yeah,
confused.
but why
Wait, you
calculate these non-uniform choices? That kind of
Yeah, so I'm sure some of that stuff will get cleaned up at some point.
Okay.
So now this is,
Yeah, and then with range, for example, it's actually quite annoying because sometimes you forget the second one and then you think you're iterating over the value, but you're iterating over the index. Right? And then I actually had a case where you had sort of two type errors, like canceling each other out, and it took me months before I found the bug. So it was a benchmark, right? So we were testing, oh, performance is great.
yeah, so in this context it works. You're right. This is a bit strange. It is. Yeah.
You show that the return value is to be named, in which case
Oh.
you don't need to declare the return value.
That's, yes, that's, so that's,
It's a handy shortcut.
that's, is 3, and it still compiles and runs. So these are like pre-declared variables. They will be initialized to 0. Every type has a defined 0 value, and you can assign them. They live in the scope, just outside the scope of your function. So, which is annoying because it means you can do this. Oh no, you can't do that. But
This is new, by the way. This was just allowed in.
I don't keep track of what's new in this language anymore. I'm sorry. Yeah.
So return is required, right? You have to
Yes.
write return at the end.
Yes. Although that's not a language spec, but it happens to be true in all versions of the compilers that are out there, and it's deliberately left unspecified because it might go away. But so currently it is a prior error, and because it's hard to prove otherwise that you return somewhere. So there's no in very old versions of C. If you don't put a return, it will just walk into the next function. They took that out. Maybe I can show composition. Yeah, so let's start with the type.
Food. Hey.
Okay, and this food is nice. And this foo has a method string which returns. Oh, sorry. No. So, see that? And it returns. Return 40. This is a very interesting type. Now, I say type bar, and bar is first of all a and it has a wobbliness. So it's 64. Now, I can make var b bar and b. magic. What happens is that if you in a struct just put in another type, that itself doesn't have to be a struct, then all the fields and methods of foo become accessible directly from B, provided there is no confusion or conflict. So if we now have a func B bar string, then this will so there's no confusion here. You said bar has a string. Okay, you get the string from the bar. So this one's not hidden. You can still call B dot foo. Oh, B dot foo. And then you get 42 again. So you can do this with multiple number of types, and as long as there are at the same level of interaction no two methods or fields with the same name, the bar figures out.
And it doesn't create subtypes, so maybe you can call this inheritance, but it's definitely not subtype inheritance. Sure. There's no type.
It's completion.
So you said before you do cast and fins and float explicit to avoid mixing stuff up, but
Yes.
this looks like a lot of implicit magic going on.
There is no, where is the implicit magic
I
going?
mean, you don't define that the bar should take the string of food.
Ah, no.
Or something.
So, no.
By definition.
Fluent in his documentation says, I will print things as follows. So this is the arguments of Fluent are type empty interface. Anything satisfies the empty interface. The documentation clearly states, if it's an int, I will do this. If it's a string, I will do this. If it's something that implements string, I will call it. So the only magic that's going on here is that here, println actually looks at the dynamic type of the interface to figure out that there's a stringer. Which stringer it is to avoid you having to make all these forwarders. There's a special syntax. So you put foo in there without a field name. You just put it will create something that has the field name and the type name the same, and it will do the composition of methods and field things. But if you said, instead of this line, if you said foo, then the composition would go away. You would have to always explicitly reference it. So you have control over the magic.
So this magic comes from the implementation of print and not from the language.
Exactly.
Okay.
Exactly.
And so and also you can compose you can compile a object. So like if you create a node and you want to compose it into bar, and you want bar to not only inherit all the capability of a new op instance but an existing op instance, you can just as a pointer initialize the composition. Like, so it's in a way it's much more dynamic. It's really a dynamic composition again. Much more, way more dynamic than inheritance.
How are exceptions?
That's a good question. They are built in with magic. So there's a built-in function called panic. It's a non-reserved word. This is interesting because it means, let me get it. Func name. Panic. Hi. Oh, this is another thing that Johan forgot to stress hard enough, in my opinion. So one of the nightmares of giant C++ and Java programs is all these imports that turn leaky and bit plots and are not really necessary. And then at one point you think, oh, which one do I need? And you put in 5 things that you think maybe better. So in Go is an error to import or define something you don't use. same with variables. You can force your way around this by assigning to the underscore variable. And so I can say import food, and it will do all the inits of food, but not actually import symbols. But that's if you really want it, and otherwise it will only get the complaint that's down there. So let's panic. Oh look, panic. We get a stack trace, that's nice. And we can pass arbitrary things in there. And now there's a, but as I said, it's not a built-in. If I say panic, string, int. This is a built-in that might go away. It was just very convenient to have. So now it's just to prove that it's this one. It's this one. So I just redefine this function. It's only in the local scope of work. So panic is a built-in function, and it will generate stack trace. But and the runtime knows about panic, and the runtime also knows about recover. And this is S is recover. And here I say S is real. I think this should work. Ha! Of course, what I get back here is an interface. I should say. So here I've done some other magic. The type that you get back is an empty interface. You can cast things. And if this is an invalid cast, you'll get a runtime panic. But there's also a way to check at runtime if a cast, if something has the dynamic type. And there's even a switch. I can demonstrate that too. So, to answer your question, are there exceptions? Yes, there's panic. You can throw arbitrary things, and you can catch them by deferring something that has recovered. There's also the convention that in the standard package boundaries, that the standard package APIs will return error and never panic. So the pattern you'll see in, suppose this is a library function from libfunc, is instead we will return an error. Error is a built-in type, and people typically do return IE, except IE is not a valid error, but there's standard ways to create things that are errors interface. As shown before. So the convention is to return, because you can return tuples, is to return your result of type T, and then la 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 la, and then an error of type error. This is the way you'll find things coded up in the standard library. So the panics are there for you, and the recovers, but libraries don't have to try not to do that. The reason for that is that exceptions are really nice, and catching them is also very nice. But if your library can throw exceptions that you, as a caller, don't catch, it means that whatever invariance you promise in your functions, you should maintain between any call to any library functions. Whereas if you don't have exceptions, you only have to guarantee that your invariants are satisfied on exit. You understand that? So if you have this is more a general argument about exceptions. If you have some function body, some function that does things, and in the normal course of execution you return here. And your function is supposed in your design to maintain some variance. For example, this file will be open, or it will not be open and the error variable will be set. Something like that. If you have no exceptions, you'll be sure that you leave here. So here you do some call to some library. Now this library can throw an exception. that you have no idea about because you didn't read the documentation, you just wanted to, and that's the whole point of exceptions is someone here can throw something and you'll deal with it here. That's very nice, but meanwhile this thing has to be designed such that whatever is thrown down here, this invariant is maintained. So whereas it can be very useful, it's also a giant foot to shoot at. And that's the philosophy behind runtime and the standard libraries in Go not throwing panics.
But what if you panic? Will the first execute after you panic, right? Then?
Yes.
But you're also catching this defer.
Yes. So the defer that has a recover in it,
Okay.
parts those things.
What if you're panic in Go routine? What if you're panic in Go routine?
Then if you have multiple Go routines, which I can't demonstrate here, you get a nice calculation of all the Go routines with the one that panicked on top and the one where everybody else is blocked at the bottom. So there are some runtime panic. I should be more exact. If you manage to deadlock all your threads, you get a panic. There are some other runtime panics. Oh, if you cast, if you have something of type interface and you cast it to something else that it could have been, because it was statically checked, but it isn't, then it fails, unless you call it with OK syntax. If you call...
Index X out of range, right?
Index, yes. If in a slice you index out of range, that's text. Oh, then, yeah, nil. We have nil. If you dereference nil, that's invalid. That doesn't violate safety. But yeah, so a map or a channel, the dynamic variable is the nil map and the nil channel, and you can't use it. So there are some runtime panics.
In general, the panics, you don't see panics in big important projects. At least what I do is I add a defer a panic when I'm calling some dodgy library that I don't really trust, that is probably doing some crazy marshalling, something that might panic. Then I put a defer around that, only that guy to protect my program. And on the rest of the program, I use the error return files.
What's the state of the compiler regarding inlining?
I'm glad you asked. That's the other thing I did.
So that's why I asked, because I know you're you.
Oh, yes. So I put in some basic inlining. That was a bit more work than I thought. But it was very nice. So the state is that short functions that are leave functions, so they don't call other things, they don't have defers and panics in them. A couple of other conditions are in line, as long as they're short. Something that returns an expression, typically in line, unless the expression is really big. The way and that's more or less stable, and the measurable speed up, and we're all satisfying. There are some things that I would like to make inlineable that currently aren't, for semi-implementation reasons, that we didn't want to do so short before the 1.0 release. So there's a secret flag that you can document and will break everything, that you can set the minus L for Luuk. Inlining. If you repeat it 5 times, it will try to inline almost everything. And that way. For example, this panic thing relies on the runtime being able to decode the stack frame. And if you inline something, I have to put in some information in this line table to say this is not really a frame because I fooled you. So that stuff we left for later. And what was the hard? So the basic inlining, that was pretty easy to get working. You take the syntax tree, you glue it in somewhere else, but then importing and exporting inlineable bodies, which is a complete nightmare. And for reasons I won't go into, but now, if I were to enable inlining something that declares a variable, it will, the imported inline body will put this variable as a global variable in the inline package for a very silly bug that I didn't want to fix. So, long story short, it basically works, and it can be extended a bit more, and there are some bugs that would come out if I made it a bit more aggressive, but I'll fix those after 1.0, and then I'll make it a bit more aggressive, probably. And, yeah, the simple stuff works. Simple things, small things can be inline. We don't really want, we want things to be inline where the actual function call is a significant part, say half of the work of actually doing it.